It's a Express middleware request handler, and it's given a request and a response object, and then we need to do some things, and then eventually respond with a JSON response. We're assuming that we've got 3 services available to us. We've got like a user service, a promo service, and a search service, and their API looks something like this. So user service, there's like a get user method, and it takes a callback function. And promo service, it takes a keyword which we're getting given to us from the request, and it also takes a callback function, and eventually will give us back an array of promotional things, holidays, whatever, and a search service which allows us to get a result set for a particular keyword. It also takes a callback and gives us back an array of results. The problem is these 3 services, they're both asynchronous, and they both take varying, or all 3 of them take varying amounts of time to complete. So the user service takes 300 milliseconds to complete, promo service takes about 500, and search service takes about a second to complete. The problem here is that, like, although we've got like res.json, we don't have any values at the moment. So like when we've called these functions, get user, get promos, get searches, it's not like we can do var user equals, because it doesn't give us back that value straight away, because it happens asynchronously. Either it goes over the internet and queries a database, and then eventually that will come back, and that's when the callback function that we pass it is invoked, and that's where the result is given back to us. So this doesn't happen straight away. This what we're passing is a callback. It's a function, and although we can see the code inside the function, it's not actually executed as this handler function is executed. It's executed later when it's called by the user service, when the user is retrieved, and that's because functions in JavaScript are first-class objects. You can pass them around to other functions. You can use them as values and that sort of stuff. So in this case, we're creating an anonymous function and passing it as a parameter to the function getUser. Same thing with get promos, but we're passing the value, which is probably a string in here, and then we're passing a new anonymous function as the second parameter. And same sort of deal with get searches. So the problem here is that we don't have any values. We don't have anything yet when we get to this point in the program, this bit here. So it's not like I can replace this with the user service.getUser or the promos with promo service.getPromos. Like, we just don't have any values yet. So we have to wait. We have to wait until all of these things have finished before we can actually respond to the client. So what I'm going to do actually is first of all create a test to kind of show that, or prove that this thing actually works, or can work, and we'll use it each time we create a new chunk of functionality to ensure that what we've built still works. So I'm just going to call it test.js, and in here, what am I going to do? Yeah, so I need to require my handler. I'm calling it handler. And that is at index.js. And then I am going to create a kind of fake request object that we can pass to the handler. And it's just going to be a new empty object with a property called body and a keyword property in that object. And that can be whatever. So I need this request object to look like that, because my handler expects it, and we're using request.body.keyword. So I'm just creating this fake object, or this mock object even, you could call it, to kind of help with my testing. So I'm going to do exactly the same with response. And response, as you don't know yet, but what we will do is we'll call status to set the HTTP status code, and we'll also call JSON later on to respond with a JSON object to the client. So I'm just going to create two kind of mock functions that we can use. So status will take a HTTP status code. But what we'll do later, you'll see this will kind of become clear, but we'll chain these. So I'm just returning this object so that I can call res.status and then .json in the same line. So chaining them like you might see in any kind of jQuery you've done before. But don't worry too much about that. Again, there's going to be a JSON function on our mock object, which just takes an object that it needs to turn into JSON. So this should really be object. And all we're going to do is to prove that my program's working. I'm just going to log out the object to the terminal. Oh. And so now we've got these two kind of fake mock objects that we can use which we can pass to our handler and verify that everything's working. So we call our handler, passing it the request object and the response object. Our handler is expecting these two things because it is. And at the moment, if we call our handler, all it's going to do is it's going to use those services and try and get these things, but it's going to respond straight away with a JSON object, which is just this stupid little object that has nothing in it. Because, like I said, we don't have any values yet. We haven't fixed that part of the program. So just switching to the terminal. So if we run that. So what happened there was that we got a response straight away, but our program didn't actually terminate until all of those callbacks had been called. It takes about a second because, like I said, search service actually takes about a second to complete, and because it's the one that takes the longest, that's the longest time our node program continues to.
Do you know your test.js right now?
Yeah.
You're just using it as like a main node application. It's not actually like a unit testing thing at all, right? Yeah, it's just an application that requires a module.
Yep.
Okay, cool.
It's an application. It's just a script. It's the simplest possible thing you could do to test your node application. Just create a script that uses a different module and then make sure that what you get back from it is what you expect. So yeah, it's super simple, and we can do stuff like we can even put a timer in here. So if we measure from the start of what time it is at the start to the time at the end. We can then run that again and see that it took, well, not very long at all. But the problem is we're not timing how long it takes for all of our services to complete. We're timing how long it takes for this function to run from the top here to the bottom here and respond. So anyway, let's start fixing up this script. What we need to do is somehow orchestrate these asynchronous operations so that we know when everything's finished, so that we can then respond. You can do this in a number of ways. You can basically have an object that you add things to, and then once you know that all of those things are there, like the properties are not null, then you could respond. What we're going to do today is just have like a counter of the number of asynchronous operations that are happening right now, and then we're going to decrement that counter every time one of these operations finishes, and once the counter reaches 0, we're going to respond. So if you have questions, then do just shout out.
What have you got something like a concept of timeout? How do you deal with that? Right. So right now you've got a counter decrement, so once like from 3 goes to 0, you respond.
Yeah.
What if before you reach 0, you passed like an hour, and that's unacceptable, and you want to terminate before time? You do something. I mean, like you can answer later. Or
yeah. So you can just do a regular set timeout. So this is a normal JavaScript set timeout and specify like shouldn't take more than 5,000 milliseconds, and then do a res dot status something bad happened. Message. Set timeout and set interval are global functions that you can call in JavaScript that delay the execution of a function and for the specified amount of milliseconds. So that's how you do that if you wanted a timeout for something happening. But then for like HTTP requests, you don't necessarily need to do something like that because your client will time out if it doesn't get a response within a certain amount of time anyway and drop the connection. So yeah, let's get started. What we really need is like a kind of empty object, like a box where we can collect all of the things that we're going to get asynchronously. I'm just going to call it. I'm not going to call it result. I'm going to call it data. And this is an empty object. So empty object like this is equivalent to that sort of thing. If you're that way inclined, you would be mad to write this out every time. Just shorthand. So yeah, it's kind of could be confusing because curlies also denote scope in JavaScript. So fun times. But anyway, so data is going to initially be an empty object, and what we're going to do is every time that one of these things completes, and when we get a user, or when we get some promos, or when we get some results, we're going to add them into the data object. And because we've defined data up here, we've actually got free closures over the data variable, so we can still refer to data from it within this function here, even though we exit this function scope. Here we leave, and then eventually these callback functions are called later on in the program. They've still got a reference to this data variable because they're closed over it. Now, yeah, so there's that, and then like I said, we're going to have like a kind of count, and in this case, I'm going to call them tasks, and there's going to be 3 tasks because there are 3 things we need to do, and we're just going to start from 3, and we're just going to decrement each time. So, for example, oh yeah, what I didn't explain is for the user part of user side of this, I want to actually return, rather than the whole user object, I want to return a property on the user object called profile, just because, why not? So what we can do is we can say when this finally returns, so after however many milliseconds that was, 300 milliseconds, about that, not guaranteed to be that much, or even more than that, what we can do just specifying a new property that didn't exist before and set that to be user.profile. Cool, and we'll do something similar in all of these. So we can do data.promos equals promos, and data.results equals. Now we don't need this anymore because we know that this doesn't work. We don't have any values at this point in the program. We need to respond once we've got all of these things together. So we know that we've got all of these things when the count reaches 0. So what we need to do is every time we get a piece of data or a chunk of thing asynchronously, we need to decrement the count. We check if the task count is 0. Then we want to respond with data. That makes sense? Yeah. And this would work if user takes the longest, but because these things are happening asynchronously, we can't guarantee that the user will take the longest. It could be promos, it could be searches. We just don't know. So we have to copy and paste this stuff into each function, right? Cool. Except not so cool, right? What's okay? So there's a couple of problems here already. First of all, we're not dealing with any errors. So if an error occurs here, then user, that's almost certainly not going to be an object. That's probably going to be null. And then we're going to get to here and be like null.profile, and then JavaScript's going to be like what? And then explode in your face and possibly pop your whole process. So we need to deal with errors. How do we deal with errors? Usually in Node we use an if. If there was an error, what do we want to do? Well, we don't want to continue. We don't want to write that. That's for sure. We don't want to continue on any further. We don't want to get down here and do this stuff. Like this is like all of this stuff. No, because if there's an error, then we don't want it. Like I said, we don't want to get to here and do a null.profile. We want to stop. We want to return. So we want to return with a status, a bad status, like an error happened status. And also, it might be pertinent to respond with a kind of message to the client so that they know what's happened.
Do you not also want to have some kind of closure of a third variable called like went wrong already, so that if there's like a return on the promo service and the other service, you can like make an error as well? Or is that necessary? No. Is it necessary?
Yeah, no, you're absolutely right. So I was going to say we should log out the error for our benefit on the server, but we should return a friendly error message to the client. But obviously, yeah, we want to do this. Sorry, I'll get to your question in literally just a second. We want to do this in everything. Yeah. The problem is, what happens if two of these asynchronous operations error? We're going to try and use this res object twice, set the status, and send two messages back to the client. That's probably not cool. So, yeah, like you said, we kind of want a. Did we err yet? Does that make sense to everyone? Shout if it does. Cool. So if we haven't errored yet, then we'll send a 500 because we don't want to wait for everything to finish before sending back an error because why? We might as well just respond straight away. But we have to still make sure that we haven't sent back an error status yet because although we've got an error, we can't guarantee that all these other things aren't. We can't stop them from coming back because we sent them all off and eventually they will come back. But whether or not they'll error, we can't know for sure. And we've got a guard around sending just the regular 200 response and the message, because if one of them errors, then we're returning here, so our pass count will never reach 0. So if we've not errored and there was an error, then send a 500 status and set erred to true. Do this everywhere. Okay, so we fixed the error thing, but are you guys happy with this code? I'm not happy, but I mean, let's just see. Let's see if it actually works, though. Sweet. So you know what the test code does. Test code just logs out whatever object we give to the JSON function of the response object. So it actually works. So that's pretty good, right? It took nearly a second, which is about right, because that's how long it takes the user service to respond or whatever. But it has given us back some things, and so we've got a promos, we've got an array, and we've got results, which are an array of 2 things, and we've got our profile. That's pretty cool. But this is really not great code because we've got some repetition. like here, like here, like here, here, like here, like here, like here, like here, like here, like here. Oh no. Here, 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 here. You know, this is kind of getting repetitive. But also we've got this magic variable here. What happens if we wanted to add another asynchronous task to our handler? We could add it in, and then we can copy this code again, this bit and this bit, and also remember that we need to increment the task count. Magic variable is not good, so we should really do something about all of those things. And not only that, but our kind of orchestration of these asynchronous activities are all modeled in with the work that we're doing, our business logic that is actually kind of retrieving things and setting them up, and that just feels wrong. So let's skip through a few. So why don't we? Any questions, by the way, yet? No, cool. So why don't we take a step back and think about what we're actually trying to do here? We've got like 3 tasks that we need to get done, and we need to do every task. I mean, that feels like there's like a list of tasks or an array of tasks, of jobs, of things that we need to get done. They're all asynchronous, and that kind of feels a bit like we could just iterate over that, or it's like a loop. You know, to get things done, we need to iterate over them and then do them. And what we could do is, if we had like let's say like an array of tasks, then our magic variable task count would literally just be the task's length. So we get rid of the magic variable, and then when all of the tasks have completed, what we actually want to do is we want to do some work. Like we want to deal with the error if there was an error. And then we want to respond with some JSON, and that chunk of work feels a bit like a callback. So we've got like an array of tasks, of things, and then a callback that needs to happen. And so why don't we split out our task? Why don't we kind of do something like that? Like, why don't we have a tasks array of things that we need done, like an array of functions, because functions are first-class objects. We can just put them in an array and we've got 3 tasks, so we could have something like this, right? And then we do the work here. And what if for each task we had, we called a callback when it was done, and then when all of the callbacks have been called, we know when all of the tasks are complete. So why don't we pass a parameter into our functions, a callback. Let's make it that we call when we've done the work. So if we do some work and then call a callback when it's done, and if we give it back an error, but potentially null because no error happened, and then like the thing that we got is doing asynchronous work. So this might be our user, or it might be our promos, or it might be our results from our search. So this is the contract we're going to use. We're going to say, okay, well, tasks is an array of functions of bits of work that need to happen asynchronously, and when they're done, I'm going to call a callback, and then when all of the callbacks have been called, then we know that that everything's done. So let's do that. Well, how do we do that? We need something like, we need the code we had before. Getting a user, yeah. Rather than dealing with any error that occurred here, we can just propagate it up to in our callback. You see the signature for this function here and the signature for this function here are the same. So what we might do, what we'll do in these other ones is we'll replace that whole function with just callback. But in this case, we can't do that because actually what we want to do is we want to say if there was an error, then call back with an error. Otherwise, call back because if you remember, what I want from the user object is the profile rather than the user object in its entirety. So we're not really dealing with the error. We kind of are, but we're passing it back up. And I couldn't do something like user.profile because again, if there was an error, that might be null or more likely undefined, right? So yeah, put that back to how it was. For the promos, what we're going to do is this. Promos. Oh, so we've got the keyword. That's cool. And promos, because it's a node program, it uses callbacks, and because all node programs, whenever you're using callbacks, they all expect the arguments for the callback to be in error first, then result. We can kind of, it's quite easy to sort of use this callback function to pass it straight in because they are the same signature. So like I was doing before, so if there was an error, then that would look like callback object undefined. If there wasn't an error, then that would look like undefined. Right. So we can call back using the parameters that have been passed to our function, and more succinctly, we can get rid of that altogether because promos they have exactly the same signature. So that's nice and succinct. And then for search results, exactly the same. Slightly longer for user because what we want to get is the user profile, but whatever. It's all cool.
You get user should it be else?
Sorry. Yeah. You're right. You're quite right. So else or return. Yeah. Often you'll see in Node programs that Node programmers will return early from functions because it keeps the indentation low, which is apparently problematic. And so, okay, so now we've got an array of tasks, a list of functions that we need to execute asynchronously, and we need to know when they're all done. So, like I said, tasks we should probably iterate over that and start running the tasks because that's what we want to do. So what we can use is as an array, a method on array called forEach, and the forEach function on arrays takes a function to be called for every item in the array. So it iterates over the array, takes a callback for every item, and then we get it gets given as its first parameter the current item that it's iterating over. So what do we want to do? Oh yeah, that's what we want to do. So we're going to call this task function. This is task. So this is like calling. So for the first item, we'll call this first function here, and we need to pass it a callback because that's what we specified here. So we're passing it a callback, and then we are expecting from the callback either an error. So error or the result, and the result could be user, it could be promos, whatever, but we don't know in this iteration, so I'm just going to call it result. And So we still need this stuff actually. We don't need this task count. Oh, here we go. Right. So we do want these things. We want these things. We want them up here. Our magic task count becomes task.length, right? And our urge, that can still stay because we still need to figure out. We don't want to reply with an error twice. We don't want to call our final callback twice. So what I'm going to do also is kind of create this responder function, which is going to be like the callback at the end that finally responds with the JSON payload or responds with an error. So I'm going to call it responder, and it will take an error, and it will take what will it take? The data that we accumulated. So this will be data. And then if there was an error, status bad thing, and then respond with some JSON. I'm just going to give it a friendly message. And if there wasn't an error, no error occurred, then we're just going to do res.json, and we're going to do respond with data. Well, so we're still going to do our whole task counting. We know when an asynchronous task is completed when it calls the callback. So in here, this is where I need to put that code that was doing the whole task count decrement, and then check if if task count is 0, and then call the responder, which is down here. So where we've got lots of stuff here for repetition. So when a task is completed, we've got the result. What we need to do is decrement the task count. If task count is 0, then we want to responder, call a responder. With null and no, we don't, not result. Sorry, because that's the result of the current task. Because we're still going to use this whole closure over data and append onto it, or put stuff in that particular box sort of idea. What are we going to do? Right, so we need, for each task that happens, we've got a result. We need to add it onto data. And what we're going to do is make data into an array and just do data.push the result. We're also going to handle the error as we did before. And then what we're going to do is call our responder with the error and return here because we don't actually want it to get any further.
Question. Task count is a global variable is used by 3 different threads. So should any the access to this variable be synchronized to avoid any possible?
Which variable, sorry?
Task count.
Task count.
It's never in the same.
There is
only one thread.
There is only one thread in JavaScript.
Even if you have 3 different processes.
You have 3 different parallel tasks. When your code is running, your code is the only code that is running. So there is no problems with locking. So I've just deleted that old code that we had. What's really nice now is that we've got kind of our work up here. We've got kind of the callback down here, and then we've got the orchestration of the tasks in the middle here. Does everyone understand what's going on here? Because this is a pretty complicated part of the program. News is good news. Good. Okay. Can anyone see? So what the problem here is, because actually data is now, because we're pushing onto this data, and I've changed this to an array because it's just easier. Because they happen at different times. I don't know which one is coming in and when. I don't know what it's called. So actually, what I kind of want to do is I kind of want to have like a map, and then be like, you know, like this, like data 0 promos. Can anyone see what the potential problem might be with this?
Yeah, that already not.
Does anyone know? Correct. Does anyone know how to fix that?
Instead of pushing, we can easily put at the particular index. Instead of data.push, we can
put it in the right place.
Yes.
Okay. So how would I do that? We want we kind of want something like that, right?
Yes. The index here pass from the function.
So for each has the signature for the function that you pass to for each is it's item, so it's function item index and array. So this is the full thing. This is the current index in the array, and this is the current item in the array. All of them are optional. All of them are optional. You can iterate over it and not pass it anything. You could iterate over it and just like count the number of items, the number of times that function was invoked. They're all optional. But index is useful to us here because we want to then use it in data and so we want to put the result of the task in the same index as it appears in the tasks array. So we know that profile, which is the first thing we got, and then promo, which is the second thing we got, and results are all in 0, 1, and 2 index of the data array.
Question. Do you know, like an array, if I put something in index position 2, result of that?
2.
Be 2.
Yeah. Sorry, arrays.
Okay.
Yeah. Unfortunately, yeah. Overcome it. Yeah. You don't often insert into random positions in an array. You do in this instance. This is okay, because yeah, it totally works. Okay, so I'm testing the exact same file each time, so as long as it works, and it works, that's good. But the problem is we still got magic numbers, like we still got 0, 1, and 2. Yeah. Like if we wanted to add a new item to a new thing, a new task, like another one here, then how are we going to get that into the output? That's just going to be, we're just going to have to add another. Data was an object, and we want to add, tasks. We kind of want to get back in our responder. This data should be, we just kind of want to respond with that data object. So what we really want is our tasks to kind of be named. So what if we did something like this? Like, so this is going to be like profile, because this is what it's going to get, and this is going to be promo removes promo, and this one's going to be results. Now, so our tasks is an object now, so it's not an array. We can't iterate over an object, but we can iterate over the keys of an object. We can use object.keys. Object.keys is super useful in JavaScript. If you've ever iterated over an object with for and in, then you need to do a hasOwnProperty check to check that the property that you've got is actually present in the current object and not in the object's prototype or its prototype's prototype. So object.keys kind of gets rid of that check for you, and you can just use object.keys, get an array back, and then we can iterate over that. Except the problem is that we don't know how. We no longer have a task and an index, but we do have like a task name, which is cool because it means that I can just we can actually get hold of that task by referencing the tasks by task name. So that's cool. We've now got this this task name. We've got the task as we had before, and it kind of means that we can maybe, instead of using index here, we can use task name. So data is an object as it was before. It's got properties which are defined by the set of tasks, and it when we get to the responder, the callback, is that tasks.length is no longer going to be a thing unless we decide to put a length property in there. But then that's going to screw everything else up, so let's not do that. But we can use, get, instead of the length of the task, we can do the length of the number of keys, the number of things we want to process. So then we're kind of perfect. All right, great. So we've got this orchestration code here. We've got the task that we want to perform, the work that we want to do, and we've got the callback. There. Let's just check that still works. Good. Totally works. Yeah. What do we do now? I'm done with that. Oh yeah, right. So this bit of code here seems as though it might be something that you could do or would need again and again if you had other request handlers that need to do asynchronous I/O and those tasks didn't depend on each other as we have here. So you can get asynchronous tasks that do depend on each other. So you need the result of the first one before you can continue, in which case you need to, in the callback for the first one, you need to then send off the request to get whatever it is you need to get. But in this case, we can send off all of them at the same time, wait for them all to come back, and then have like a callback call, which is our responder here, when everything comes back. So why not make this into a module? I'm going to call this module async. Async.js, and I'm going to use it in here. Async. Cool. In async, we basically want this stuff, all this stuff. I'm going to cut it because I don't want it in there. I can put it in here. What async's going to do? What async's going to do is it's going to take a set of tasks and a callback function. So it's very similar to what we had before. We've got an array or object of. This is only going to take an object because that's what we had last. But this is going to take an object of named tasks that it needs to do, and then the callback, our responder, as the function that needs to be called once all of those tasks are complete. So pasting all of that stuff in there, data is an object, this is all exactly the same. Do I even need to change anything here? Oh yes, I do. Okay. Looks good, right? I wanted to use this. We can do something like here's my callback. So orchestration has now been pulled out into a module. Can I keep one? Yeah, if you want. You can name any function. And that means if you name a function, then you can refer to it from within the function. Which is quite nice sometimes. One of the properties too. But it's also useful for stack traces. If something throws in that particular function, then you'll get a name. So it wouldn't be like an anonymous function. It would be a responder. So sometimes people leave that in for that reason. So we've got like not very much code here at all. We've got 3 asynchronous tasks that we're juggling, and we're then calling a callback. So our responding code is all kind of grouped together. Our work is grouped together, and our reusable orchestration thing is grouped together as well in its own module that I could publish to npm. Turned out someone already did this. Not only that, but it's one of the most popular modules in npm. It's one of the most used things in Node. And it has something called where is it? So many. Parallel, that's it. Sorry. Parallel. Run the tasks. Call a callback. So we had an array before, and a callback function, but we changed it to be this named set of tasks that we need to do and the results. So that's a thing. That's a thing for dealing with async in Node, and it's a really well-known and used module. So any questions on that? That's one way of dealing with async.
It's interesting how that terminology may be misleading, because you say that you run the 3 processes at once, the 3 functions, but in Kubernetes you are not doing that because it is a single thread. So
it is a single thread. It's parallel in JavaScript.
The each function at the time. But they're saying functions at the same time. Yeah.
But you're dispatching those requests.
Yeah. I understand, but
the external providers, right?
But the terminology is the terminology.
Yeah.
That's interesting. Yes.
But if you wanted to do what Alan's just been doing there in terms of dispatching tasks using multi-thread, you can do child processes. You can have workers that you can use for the cores if you want to. But then it does become a little bit more complex. Like the async doesn't handle that for you.
You have workers with running in different threads.
Yeah. Yep. So you can spawn other node processes. Usually you'd spawn about as many as your CPU core has cores, and then you can do work, but you never share any memory. You message pass, you copy, so you never get any. You never have to lock. You never get any concurrency issues that you get with Java or C.
So this is like same execution with parallel, sending up.
So I can try and explain the event loop and how things happen in Node again. We covered that last week or the week before last, but worth looking up because it explains you understand how Node works and how you can have non-blocking I/O and still service requests from thousands of people. So anyway, that's async. that's the async part of what we wanted to cover.
Does it answer your question, or do you want us to?
No, it's okay.
Okay. So this was a lot of callbacks. We encountered a lot of closures and things in here, and we used the async module, or we created our own async module, which deals with parallel stuff. There's so you can do async waterfall. We'll do things in serial, one after the other, and you can pass an object from one part of the waterfall into another, and you can gradually build up things. So the other method of flow control that I was going to talk about today is we should try. Did I make sure this works? Yeah, okay, it still works. Good. Other part of flow control I was going to talk about today is promises, and we're going to start with like a really similar starting point to what we had for async, except our API is now going to be like user-service.getUser, and what that does is it returns a promise object. Promos returns a promise object as well. GetSearches returns a promise object. So. Yeah. Absolutely. I'm hopefully going to show you how. So promises are an IOU, and a promise is a value. So one of the first things I said was that the problem is at the start here is that we don't have any values, so we can't return anything here. Whereas with promises, you do get values. You get returned a promise object, which is essentially later fulfilled or rejected. Importantly, it's only fulfilled or rejected once, so you don't have to have this dance with the have I replied yet. So you can use that promise before or after the value arrives, and you can chain promises together to kind of build up a method of achieving asynchronicity. So important things about promises, they will all have a then function, and promises a plus spec basically identifies a promise as being thenable, and then it is essentially a function that accepts a function which will get the value of the promise when it is eventually fulfilled, or it will also get. You can also give it other functions that will receive the error when it's rejected. And then we'll always return a new promise for the return value of the function. Cool. So how would we do something like this using promises instead of async? Well, just like okay. I should probably explain that promises are not native to Node. Like callbacks are. Callbacks are not really something that is different to just plain functions. Well, you're late. You're terribly late. Just like async, promises are something that you'll have to install using npm because they're a library. They're a chunk of code that allows you to, an abstraction over, just like async, that allows you to deal with synchronicity. So what we're going to do today is just use a library called Q, which is a really popular async, promise library. So require Q. Should probably move into this directory. Q. Install Q. Cool, so Q has now been downloaded, and you should see it in your node module folder. Because in the docs they use a capital Q, and I don't want to confuse anyone.
That signifies stuff. That signifies what it's special.
Yeah.
There we go. There's a Q. They use a capital. So that's what I'm doing. Good. So we're going to use Q, and what we can do, because we've now our API returns a promise, we can actually use Q and essentially do this stuff in like very little code. But so the problem is that if we wanted to do a normal promise sort of flow, we might be doing something like then, and then give it a function, and then we'd do like, I don't know. So this is kind of chaining it, but what we want to do is not chain it, because all of our asynchronous calls don't depend on each other, so we don't need to chain it. But we can use something called q.all. What q.all does is it accepts an array of promises. And if we call our APIs like this, return promises, we return straight away and they give us back a promise. Whereas before, we were giving back nothing. We were giving back undefined, because they don't return. They give us back their value when, or they did used to give us back their value when in the callback instead. So q.all accepts an array of promises, and it basically turns it into a single promise, which will be fulfilled when all of the promises in the array are fulfilled. So that's really useful, right? It's like the async parallel function, in that we gave it an array of tasks to do, and then the callback is called when all of those tasks are finished. So we've got a similar sort of idea going on here. So we can do.
But it has some kind of going time, because if one of those have to consume something externally, and that something externally is down, what will happen? It will fail, it will give a timeout, or it will execute partially the rest of the code.
Yeah, so they can fail, it can throw an error. Either way, you'll be able to deal with it. You can use a .fail. Yeah. You can give it options to not fail fast, but why would you ever do that?
What is the time between one over the other? I mean,
so with promises, you're still going to do asynchronous operations, but it's just a different abstraction over dealing with asynchronous I/O. That is for you to decide. Yeah, I don't want to tell you how or which method you should use. Node core only uses callbacks, so there's that. But there's a lot of other reasons for using promises. And yeah, you should really make your own mind up once you've explored them. You should definitely try them out. If you're using Angular, then you might have to use promises anyway. So often it seems to be not often, not always. Front end promises, that fits really well. Back end, because Node, if you're interfacing directly with Node, then you either have to wrap Node's callback stuff or just use callbacks. So I don't know, maybe you choose to do it that way around, where you have front end promises, back end Node, or maybe you want promises everywhere. Promises. I don't want to make your mind up for you, but so what we get is a data that this is actually going to be an array of the things that we've asked it to do, and they'll be in the right order, so we don't have to worry about that. You know how we had that problem where our asynchronous stuff was coming in different orders, so we can literally just do a res.json here and do a this is what we want to do, profile 0, and we'll promos 1, and I should mention that there are other promise libraries. Q is just a really popular one. And results. Here 2. Cool. And then here, if there was an error, then we can just do a res.status 500. Excuse me. JSON. So it's kind of as simple as that. We've now got our handler that responds with JSON or fails with a 500 and a failure message. So that's quite nice. What I don't like about this is the whole array indexes. Luckily, what you can do is, so Q has this thing called spread, which will essentially spread the the results of these asynchronous operations over the function that it calls back to. We can then do something like user promos and results. Okay, well, so that's a little nicer. You want to spread stuff. And then, so what the interesting part actually becomes how we alter our API that might be calling node functions or like DB functions that traditionally take callbacks. How do we alter our API to return a promise instead of taking a callback and responding in the callback? Well, let's do that then. So let's create the user service from scratch, right? So add a folder. Let's call it user service. And then what do we want? So the minimum stuff we can put in there is we need like index.js, and that's where our JavaScript's going to go. But we need we need package JSON. Does anyone know what the minimum things you need to put in a package JSON are? Version? Correct. Version? Yep. Anything else? No, it's just name and version, because you don't have to have any dependencies. Main is if you don't have it, index.js, so it assumes index.js. If you don't have a main, if you want to change it from index.js to something else, then use something else. So we're going to call this user service. Sweet. So you need a name because you need to, when you require it, it has to know what name you want to refer to it by. It needs a version because it needs a version. You always have to have a version. Yeah.
Use npm init.
You can use npm init. Yeah. Okay. Well, let's do that.
Yeah. But npm init is not good. A lot more.
It is.
Fields.
Oops.
We are talking about position model. You need to have all the fields. Right?
You only need to have two, but okay, so if you're starting a new node project, which I've done with quite a few of you already, I would normally recommend that you start a new node project using npm init. And npm init is like the easiest way to create a new package JSON file. And it will ask you a bunch of questions, and you just have to answer them. In brackets is what it's going to put if you don't put anything in it. So I want it to be called user service. I want that version. I'm not going to put a description. Entry point is index.js. Test command, no. Yeah, and whatever. And then it was yes, this is like okay, yeah, that's fine. Then we've got a package JSON with some fields in it. But like we were saying, the minimum two fields that you need are name and version. So you can manually create your package JSON and create a name and version.
But to deploy to publish to npm without the fields.
Yeah. If you're going to publish, then
everything.
Yeah.
Some guys don't put the GitHub, and I don't use that module in my code. Sorry. Right?
Yeah. Yeah. Be friendly to your fellow developers.
Yes.
put all the information in because you might need it. And yeah, you know, it's just good practice. But I'm just saying the minimum is name and version. Cool. So we're in user service. So this is the user service. How do I change the user service? So okay, well, so first of all, I've got to kind of create this fictional user service right first. So what I'm going to do is I obviously need queue because that's what I was using before because I want to return a promise. Queue. But what I'm going to do is I'm going to use a in-process database called LevelDB, and if I want to do that, I'm going to need to install it. So let's go back into there again. User service, npm. So I'm installing within my node modules folder within my module folder because this is a dependency of the module that I'm building. So npm install.
Can I stop you there?
Yeah.
So you want to install that level thing for being used in your user service, and therefore you go to node modules user service and you install there and it install it inside that module but not.
Because this is a dependency of user service. It's not a dependency of anything else. So normally what I'd have like a folder somewhere else on the file system. But I'm kind of cheating and I'm already putting user service into node module because I know that's where I want it to end up. So I'm just building it in place, essentially. But yeah, I'm in node modules user service and I'm installing a dependency called level up. I need that, so I really need to save that because this is a runtime dependency. I need it for my module to work, so I want to save it to package.json. And I need to install queue as well because this module uses queue. And I need to save it. We've now got. No, it does not. It will install it to node modules. You'll be able to use it in your node program, but it does not add it to package.json. If you want anyone else to use your module or work on your module, then you should add it into dependencies into package.json so that when people come to work on it, they can just do an npm install. When people install it, that means that the dependencies will be automatically installed for you. Yes, definitely always save it. If you want to, if you've got a testing framework, if you've got like a TAP or something and you want to test it, then save it into the dev dependencies section of the package.json. So, whatever. Oh, sorry. Now I've got a dev dependency section with TAP in it. Cool. So this is my module. This is my user service. All I'm going to do is access a database, a database which takes callbacks. So I need to kind of somehow translate this callback style module called level. Well, I'm using level up. It's really useful for working with databases. For you working with level databases. So let's actually do that. So I installed queue because I'm using queue. I need level up.
The key store database.
Yeah. LevelDB is a NoSQL key store in process database, so you won't be able to access it from anywhere else. What I'm actually going to do is I'm going to the store is actually going to be in memory, so I'm going to use a module called memdown. So I should install that as well. Up. So I'm just creating creating the boilerplate for accessing my database in the first place. Just telling it that the values that I put in, they should be stored as JSON and retrieved as JSON. And then, because this is the user service, we know that the user service has a getUser method. So we're going to do module.export.getUser, and this needs to return a promise. Using Q, we get a new deferred object from Q, which we will then later reject or resolve. And then we do the business. We can use our db.get, and db.get. We're going to get the current user. So we're just going to have a key called user, which will have an object as the value. So per user, per. Sorry, skipping back down here, we actually want to return the promise. We want to return the promise object, and what we'll do is we'll reject or resolve the deferred object when the user object is retrieved or everything explodes. So in this case here, if an error happens, then we want to reject, telling it that the error is that error, and otherwise we want to resolve, telling it that this is the value that we want to resolve, which we want to use in our future. So that's kind of our API. That's quite long. That's kind of a longhand way of doing it. But you can also do like Q has these awesome kind of wrappers, which is what all we're doing. We're wrapping around db.get and using promises, returning promises. It's quite a lot of code to write, but it's something that you'd need to do, and the kind of format is and so Q has this wrapper function which allows you to transform a node style call into a function that returns a promise. So we can actually do something like this. This is really similar to using the function.bind function, in that we are telling it that we want to bind this this get function. We want to give it the context db, so this would be what this refers to in get, and we want to, and then the rest of the arguments are the parameters that we want to pass to the function that is given back to us. So like we can literally do it in a one-line this thing, but to prove that what we've done above works, I'm going to comment that out for now. I'm going to create a function that allows us to set the user, put something in the database in the first instance, so that we can then retrieve it later. I'm going to write a test script to just make sure that this actually works and works as expected. So q.nbind. DB, for putting stuff into the database, you use db.put, and we'll tell it that to put in on the user key. So that's essentially our module. We've got level up, mem down, and q, and tap, even though we're not using it. Cool. And so what we're going to do is create a test.js in the promises section. And then in there, use our user service. What we're going to do is we're going to set the user first. I'm just going to give it give it a profile and a name, like that. And because it's a promises API, I can then do a .then. So once that asynchronous operation, which would normally take a callback, has completed, then this function here will be called. And then I can actually call my user service user function, which returns a promise. And then, when that's resolved, it's going to log out user.profile.name. And call done, done. So this is what I'm going to use to test my module. So I should just be able to now back up a little bit and then test. Yes, right, I can never spell that. Cool.
Can you show the code again with the two thens? Because that's not how to that I did that. So the first then is when set user completes, no? And then you enter in the first then, no?
Yeah.
But I don't fully understand the second then. The second then executes when user service dot get user finishes, or when?
Yeah. So because we're returning a new promise.
Well,
yeah, we're returning a new promise, which is the get user promise. So we can continue on using the next then.
What is the?
We could have done sorry, what's that? We could have done this. If that makes more sense. But then we're kind of
that is the way I was
indenting.
imagining it. Yeah.
But because I've returned the returned here, then the promise that, so then if you remember from at the start, then always returns a promise, and it returns a promise which is the value, which is potentially the value that you return here. So then you can continue on. Any questions?
Like this then, done, and this other stuff. Like, what is the interface difference or SS?
So then is the thing you need to know about most.
Yeah.
And that's kind of it. You can then can also take a second function for the error,
Yes.
if you want.
We can talk here about the fact that the first then on line 5 returns another promise. That's why you can change it then on line 7.
Yeah.
On line 8, we just did a console log. So therefore, the then on line 7, why can you call it .done? Because there's no return statement in the then, because it's just console log. So what's happening there then?
So .done is essentially. So there's a problem because so if an error is thrown here, then it will be you'll be able to deal with it down here.
Yeah.
But if you don't call done here and an error is thrown here, then it won't be because what promises do is they catch any errors in the then handlers and will propagate them up to the next continuation. And so if you don't put done here, then it will just be any error will be swallowed up. Whereas if you put done here, then if there was an error in this area here, then it would be rethrown and you can catch it.
No, my problem, my question is more to do with the fact that the second then doesn't have a return statement.
Yeah.
And how the done knows, which then is the or how?
Yeah, like that.
I mean, I don't get regarding his answer. The done is when the second promise finishes, or because
yeah, it's when the second promise.
So, so second version is without return message.
Without install.
So you know then always returns promise.
Yeah. So even if you
But
don't
some-
return something here, just return a promise that is never fulfilled. And then if you say done, it's done.
And if the parameter function returns some other promise, then that promise.
That promise is the continuation.
And if it's not doesn't return anything, it's just
So you explicitly
simple promise.
do the term. That's like the overriding.
Okay.
Okay.
Yeah.
So that is async and promises. How you'd wrap a existing API using queue promises. Oh, so we should probably. So I ran that, right? That worked. So just to show you that I've got too many. Okay. Just to show you that the other method of writing it does work. Should be able to just comment out this guy. It'll do exactly the same thing. And then the only other thing I wanted to talk about was event emitters. Does anyone have an example for why you might want to use like some sort of, it doesn't have to exist already, but something that might need to emit an event at like intervals on the Thomas Cook website, for instance?
I'm sorry, I didn't understand the question.
Yeah. You said something regarding events, but I didn't hear that.
Okay. All right. No, that's just my. I'm just trying to think of something to use as an example to explain event emitters in Node.
Okay.
Yeah. It's okay. How much time do we have? We don't have a lot of time. Good. We don't have a lot to cover.
Yeah, I know, because I'm deaf, you know.
Okay.
Okay, so let's create a file and let's create. So why don't we create like an airplane object. It's an airplane object, and at certain points, airplanes might change position. So perhaps they need to emit like a new position event with their new lat long. If we wanted to create an event emitter in Node, then what you can do is you can use something called event emitter.
One of the most important core libraries, just like .NET, will handle all the TCP connection, and the HTTP inherits from the event emitter. When you receive a response, someone is access your page, you receive an event in your server, right? Or when some client is connect your TCP server, you receive an event, right? It's just like a publisher and subscriber. Okay.
So this is for synchronizing process and stuff like that, no? Like most processes it's like a listener or the observer, no? At the same time.
Yes.
Or,
Absolutely.
Okay, so you might have encountered events using JavaScript, using jQuery when you listen for click events on particular elements in your DOM. You might have used events if you've ever used streams in Node. You might have listened for a data event, which is fired every time a chunk of data has been emitted. If you've used, that's two good examples of where you might see events.
Most common, right?
Okay, so I have within Cat we have an RSS feed. So could we potentially event every time an account's created, just publish to RSS?
So you do publish. What do you publish in your RSS feed?
It's just a feature
For this?
for another company which actually
Okay, sweet. Okay, well let's do that then. So every time a user account is created, so perhaps we've got a user, right? A user model or something, or account, a set account. Let's keep it relevant. That's cool. And when we create a new one, let's say. So what would you typically give an account? Would it have like a name?
So have account, email, password.
Okay. Cool. So then we have let's start. Cool. So occasionally we might come across a situation where create a new account model, and then perhaps we've got like a function on account model which is like save. Every time we create a new one, perhaps we have like a is new for when we create a new one, and then and perhaps we make like a HTTP post to say that whatever. We'll probably have like a level DB, right? So maybe we should do something really similar to this. We've got like a database somewhere. Literally just pretty much pseudocode, but yeah. So, user this. So if it's new one. New one, then we make it not new again, but what we might do is an event called created. It's probably not going to work that well, to be honest. Yeah, I'm just thinking. So we need a way of inheriting from the event emitter, because otherwise we're not going to be able to emit an event. So what we can do is there's a there's a util package which has an inherits function which allows you to inherit from other classes, JavaScript classes. So we can have like which means that any new accounts that you create, you can attach events to, you can attach events to, and you can emit events from. So later on, we might create a new account model with like create a new account model, and we might attach an event list now on that point and say, or maybe we should have like, I don't know, what should call the event? Great, okay. We're already emitting that, so that's good. And then so what you'll see is it's now got every new account that we create, it has got a function called on, and it means we can attach event listeners to it. And, can have like, perhaps we've got like sort of RSS feed. And we can add to that RSS thing, potentially, right? We can also do something like once, which allows you to attach a one-time event listener. So that will happen once, and well, because created is only going to ever be admitted once, there's no point adding a event listener that will stick around forever. So if you use once, it will be automatically removed. So you can, so on is like shorthand for check.
Even model is use JavaScript, or it's something specific of Node.js? This module. The same thing you can do in JavaScript.
The event emitter. The event is a first-class module inside of it. Because HTTP, TCP, all these important modules you have in Node, they inherit from
in JavaScript, no?
I'm just saying JavaScript.
In JavaScript, in browser, yeah, you can do. Not like this, but
No. So
You can do .on, or maybe I'm confusing.
Yeah.
You can do .on in client side or not?
So a lot of DOM, so yeah, a lot of DOM libraries will allow you to use a .on method to attach an event.
You can create your
No,
your event emitter library. I
With
create one.
plain JavaScript document getter and binder. With that you can do that as well. No?
Yeah, you
Okay,
can.
plain JavaScript is, what do you mean by that? Because if you add a function to any object that's called on, then yeah. If you're talking about the DOM specifically, DOM isn't JavaScript, it's just a thing built in JavaScript. And a lot of DOM objects will have, or there'll be libraries that will allow you to attach event handlers to them, to DOM objects, using a .on method. So yeah, what I'm using here so this is specifically for Node, so inherits and event emitter is specifically Node. But you can do, like I said, you can do similar stuff in the DOM in the browser. But
With jQuery.
with jQuery, or there's DOM events. It's like
I have a module to run in browser instead using jQuery, and you can simulate the event emitter.
I mean,
It's not
add event listener is the equivalent for DOM events. Yeah, like if.
But it's something the browser is giving to you to use, right?
Yeah.
Okay.
Yeah.
Something not capable to different between JavaScript and Node.js.
JavaScript
I think the
JavaScript is a language.
They're all the same sort of ideas,
Yeah.
but they're implemented slightly differently, which is confusing. So util.inherits, this is how we're inheriting from event emitter, and util is a core module. There's lots of utilities in it. Events, here we go, events here, and we're using a class called event emitter. So this is exactly what I'm doing in my code. And then yeah, you get add listener, and so on is essentially so they're just aliases for each other. And then I was talking about once, you can remove listener to remove event listeners if you don't want them anymore. Remove all listeners. You can set max listeners. So if you set too many listeners, then Node will start freaking out, because it's like, well, setting listeners is kind of like introducing a memory leak if you're setting a whole load of them and never unsetting them. So if you're going to set a lot of them, then crank that up a little bit. But you should never really need to. If you need to, then you should reconsider your reconsider what you're doing. So yeah, I mean, this is a really bad example. I'm sorry, but essentially there's not much to it. There's you require event emitter, require inherit so that you can inherit from it, and you've got your thing or your object or your class, and you inherit from event emitter, you can then use emit to emit an event with parameters. So this could be anything you want, like any parameters you want to receive as a in your event handler function. Yeah, and that's kind of event. It's another way of dealing with. It's not really flow control, but.
May I ask you something about this code as well? So you do the new, okay? So the sequence should be new calls. I understand the constructor up there, no?
Yeah.
So it sends the parameters, and I understand, but I don't see who calls save, because the this.emit it is in save, but I don't see who is the guy calling save.
Nobody. That's because no one is.
Ah. Okay. Because I was like, whoa, no, this is magic, man. There is something working there that my mind.
No, you can call this.
Cool. Now I get it.
The best was to put the email and the password in the inside in the method, right? That using in the constructor, passing here. Every time you call this, you can send to a subscriber, just like that. Okay. Basically.
Why don't you use this like event stuff over? I know it's not easy, but
So
if you are dealing with a fleet management company, yeah, it's very good. GPS tracking vehicles, for example.
If you've got more than one thing that needs to know about something happening, so for so perhaps you've got like fleet management, right? You've probably got like a map of ships on it potentially, and they've got like a position, and then when that position updates, essentially the thing emits and says, so a position is updated. The thing that's managing the map then needs to move the ship.
Point of interest. When something enters in the point of interest, you receive the coordinates, right, and you can do something. For example.
So if that new position is in the point of interest, then you might have something listening on all of the ships that are on the map, and then gives you like an alert box or something that says warning. So you've got two things that are interested in that event occurring. So both things can listen for that thing to happen and deal with it appropriately.
I think this example was not correct. Account, because it was simple, create account and send access. It's okay. It's a convenience flow. But the event should be basically upon the database, that when a new entry has been inserted into the database, then fire something.
Yeah, that would be a better example. I just made this up, and that's why you should prepare for things like this.
And you mean the same even two different objects?
Sorry,
you can have several subscribers, but you can have also several publishers with the same creator or the same even name.
Yeah. Because it's the thing the object you're listening on that's the important thing. So like it created, you could have a completely different object that does something completely different, but also has a created event. But you're listening on that object, so it's implied that created, is to do with that object and not something else. You can call them whatever. Like you could have like count created, and then you could
So how can I share in one consumer same behavior that two different publishers are emitting?
You'd have to do just listen on each one.
Okay, so it's
so just like if I've got multiple accounts.
Most of them not, but the WebSockets libraries we have, it's just like this, using this method, right? You are listening, you are receiving messages. It's two-plex communication.
Yeah. Yeah, exactly. Like, so you might have a WebSocket that's open. It's a persistent connection. Whenever a message arrives, then an event will be emitted, and there'll be listeners for a generic message event, and then whoever's interested in it can deal with that particular message. So it's up to the thing that's listening to it to differentiate and know which messages it's interested in, which is reasonable.
Can you show one more time the promises you changed your code to one line to make it work?
Okay.
I'm falling in love with promise. No, don't do that, man.
Shoot one line.
No, it's doing lots of magic. My opinion.
That line, indeed, if you show it to me and don't explain me, I will never understand what is going on. Never. Like, yeah. Q and mine, yeah, but.
Yeah. You just have to read the docs. So it's not.
No. I mean, obviously for me, it's tough because it's very abstract, as you may know. I mean, imagine that Qbean does everything that you program explaining at first sight is not really.
Yeah, I mean, I guess it's kind of why I'm going over it now, so that you guys can know in advance when you see something like that what it is actually doing, and it's doing that. Which is why I went through the async example, so that you know that the behind the scenes, this is what's happening. You know, it's not magic. There is no magic. There's no magic in there. It's just it's really simple.
How does it track when all callbacks are running? Like in async, you showed all that it increases counter and something in here, for example. How you know?
Probably in a similar way. I haven't looked into it, but probably in a similar way.
I missed in the workshop the gel stuff, the other common JavaScript,
Gel?
Yeah. And you showed me another module, the Q. Yeah.
Which module?
Q or what? I don't know.
No.
Q. That it's similar to async. I think you've promised to do async and you know, require function defect.
Yeah, like here.
Like that. Okay. But not the same issue.
There's other promises library. There's promises in jQuery.
Yeah.
Promise.
Angular.
And Angular.
Angular is lots of promise. Oh, sorry, Angular is promise.
Okay, cool. It's 4 o'clock, so we're out of time. Unless anyone has any other questions, really quick questions. So one thing I should mention is that the code for all of this, if you want to look at it, is here. There, GitHub, there. Cool. Twit flow control. So that has got both. So all of the intermediate steps that I took before we got to the async module and our regular module.
Generators. We are talking about generators.
Generators. Right.
The TJ module.
Okay.
It's different. This is for ECMAScript 6. It's better than not.
Generators are coming to JavaScript at some point soon. They are in Node 11. So if you don't know already, Node stable releases are all even, and unstable releases are odd numbers. So 0.11 at the moment is the unstable release, but you can use it and download it, and if you pass it a special flag, it will allow you to use generators. What generators are is a way of doing an intermediate return while your function's still executing. So you can return halfway through. So you can have like something like a while true an infinite loop and have a return in the middle. It's not called a return, it's called a yield. And when your code gets to that point, it will return back to the calling code with the current value for whatever it happens to be doing, and then you can tell the generator to continue, or you can do whatever you want. So it will make this whole asynchronous, or eventually will make a lot of the asynchronous problems in JavaScript go away at the expense of you having to get your mind around returning mid-function and returning multiple times from the function. But yeah, if you're at all interested, then absolutely have a go with generators in JavaScript. They are super fun. You can get, so if you've got Firefox, you can just use generators in straight away in the console here. Like, you don't have to install anything mad. You can just use them.
Can you stop and continue and pass a value or something?
Yeah, you can pass values between functions. So you can return a value mid-function and then deal with it and then resume and pass it back a value so that it can then continue. You can also resume and tell it to throw, so you can basically get your function to throw from inside it. Yeah, it's great for iteration.
Do you see working to have a look at that and do some example and try to understand that, or it's something that is not going to be used ever?
So, okay, if you're using Node in this company for a while, you will eventually use them because they are coming to JavaScript. They're in the spec. They're almost certainly going to be in ES6. They're already in Node.
The new version.
Yeah, in 0.12 you'll have generators. So, yeah, there's a you know how you've already got Express and Happy being hunted around by us, but there's another one which uses generators called Koa. So yeah, if you're at all interested in it and you're interested in future tech, then do have a look. It's really fascinating how it works and how you use it. You create generators using function star, and then you can do while true, say var I equals, sorry, let me consider I equals 0. And the problem is I can't spell yield to save in life, so yield I'm not sure I even know the correct syntax for all of this yet, so we'll see if this even works. But essentially, you can have a function that should never return. Oh, wait. We should get 0. So then we should be able to call that generator. And then how do I start it? Oh wait, I need to. I really don't know how to use it. Oh, how do I use it?
You need to yell.
What?
Use it in Firefox and do it.
Oh, I'm just going to look it up. How about that? Tells it that you're defining a generator. Right, okay, Jesus. .next, that's it. Yeah. Sorry, yeah, right. So I get value is 0, and it tells me it's not done. So every time I do that, my function's returned midway and give me the current value of I. And I can't change this value. I have no ability to do that because my generator always. So this is inside the scope of this function only. But what's happening is that so when it encounters this, it yields with this value, the current value of I, and which is why it gives me back this object with a value. So whenever you yield, you get back an object with a value and a done parameter. You get done when the function exits, but because we've got a while true in there, the function never exits. But once we call next, what happens is that it goes the execution returns back to this function, and we get back up to the while true, still true, increment I, and then yield again, and then we're back here.
Function we're running and waiting.
So yeah, so nothing's running at the moment. It's just a thing in memory that you can just like functions. Sorry.
So apart getting this value, can you do what else can you do?
With generators? Well, because you can return midway, you can basically do things like, okay, well, I'm going to wait until this asynchronous operation is completed, and then you can return back. You can pass values back to the function when you call. So when you call next, you can pass. Assign, so you could have like.
At which point do you return back to the original? So you yield and give I.
You return back after this statement here. Well, you return position. So if I had a generator like this, where I'm assigning. JSON equals yield whilst you make a request to go to some API, get some JSON back, and then assign it to that variable continue, right? So your code then appears synchronous, whereas it's actually not. But like you just saw that I couldn't even use these, so I'm no authority on this.
This is like a stream, but instead of the inverse control. I mean, the stream you read when it's ready, and here you say I want to read, but it's exactly the stream.
Yeah, I guess so. Maybe in the future they'll implement streams in terms of generators.
Can you show this example?
Yeah, sure.
Because I think it's using some requests.
Really dangerous. They need it for the router and they need it for the server. No. You can keep all the memory.
For example, in here you are getting some information from some URLs. Instead of using callbacks to wait in all the requests. In here you are getting all the response from these gets, right? And you give to the what you want to do with the result, right? If you do with callbacks, you need to put the callback in here, call this inside of the callback, and this inside of this callback is nested callback, right? And with generators, you can do all the calls just like this. It's more readable, the code, and you receive all the response in here, and you return. You can return it in here, return out without the response, right? It's more clean because you don't need to have all the functions, the anonymous functions, and
nothing gonna happen until you or next.
No? Yeah. No. Forget that part you show in the first one.
So yeah, you only have to not deal with next because
in this case now.
code the module is dealing with that for you.
It's doing that for you.
But you can see that this is essentially. So you can see, like, if I need A before I got B, or A, the response from A had the URL for B, you know, then I'd use some construct like this. And look how this is like written. It looks synchronous. It doesn't have functions and closures. It's just a lot more readable. So it's gonna be fun. It's gonna be fun times. And the promises and async, the library is just gonna essentially go away.
But because now, if you need to do some control flow, you need to use asynchronous, you need to use promise, and it's more stuff you are putting in memory. With generators in JavaScript inside of Node, it becomes more simple.
So start.